Hey guys, welcome back. Today we're going to solve Leetcode Problem 200, number of islands. So the problem statement says, given an m by n 2D binary grid which represents a map of ones to represent land and zeros to represent water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume that all four edges of the grid are all surrounded by water. So the input is just a list of lists with ones representing land, zeros representing water. And I think with problems like this, it's a lot easier to visualize if you actually draw it out. So let's take a closer look at one of these examples. So the input we're given looks like this, and we can represent it as this 2D map where the green squares represent land and the blue squares represent water. The way we define an island is any block of connected squares of land. So this is an island, and so is this, and so is this. So our solution, given this input, is we have 3 total islands. So what we can do to try to solve this problem is we'll start by looping through every item in our grid. And when we get to an item, we'll ask this question: is it land? Because that's all we care about at this point. And so when we're looking at this first square in our grid, this is water. We don't have to continue looking at that tile. We move on to the next tile and we ask, is it land? And in this case, it is. So we want to find all of its neighboring tiles that are also land so that we can consider it all part of one island. So in this problem, the neighbors of a tile are explicitly defined as being horizontally or vertically adjacent. So that means a neighbor of a tile isn't something that's diagonal from it. We can only go up or down or left or right. So first we look up and we ask the same question of whatever is above the current tile. Is it land? In this case, we can consider anything outside of the grid as being water. So no, this is not land. We don't have to continue going down that path. So then we look left, we ask, is it land? No. We look down, is it land? Yes. So since it's land, we do the same process. This is now the active tile, and we need to look at its neighboring tiles. We've already visited this tile, so we won't look at it again, but we'll go left and we'll ask the question, is it land? It is, and we repeat the process. And we find that there's nowhere we can go from this tile. We're done looking at it, and we can backtrack back to this tile, and we see that there's nowhere to go from there. So now we're back at our original tile. We still need to look in this direction. This is water. We don't care about water. So now we've looked at every neighboring tile of this piece of land. We know that we have just found an island. One thing you might have noticed when we traveled to neighboring tiles that were land, we knew not to look at tiles that we had already visited. So we actually need to ask another question when we're looking at a tile. Along with, is it land? We need to ask, have we visited that tile already? This process of getting to a tile and asking these questions and viewing the adjacent tiles and asking these same questions repeats itself until we finally get to the end of the grid. So this method that I've described is a type of algorithm that's very common in problems like this, and it's called depth first search, or DFS. And generally this is done recursively, which makes sense because we're asking the same questions each time we get to a tile. So let's flip back over to Leetcode and try to implement a solution. So the first thing that we know that we need is some kind of count to keep track of the number of islands that we found so far. And we know that we'll return our count. Now we can loop through the grid, and I'm going to use the letter R to represent each row and C to represent each column. So now we can ask our question, are we looking at land? So if grid at RC is 1, then we can do our recursive function here, which we'll call DFS. And we can also increment our count variable. So up here, I'm going to define DFS. And the first thing I'm going to do is actually mutate the original grid. We want to be able to mark this tile as visited. So we can set grid at our current location to something other than 1. So I'm going to pick 2. And now we can recursively look at all the adjacent tiles. Now, we need some way to stop the execution of this recursive function given some kind of condition. So if you think about what's happening when we're visiting an adjacent tile, we need to perform that check again to check if we're actually still looking at land. So before we execute all of this logic, let's check if the current tile is land. And we also need to account for edge cases where we're looking at tiles that are off the grid. So to do that, let's check that we're on the grid by checking that the value of R is within the confines of the grid, as well as the value of C. Okay, I think this should do it. Let's submit it and see how we did. It looks like our solution was pretty efficient. So if you liked this video, feel free to give it a thumbs up and subscribe to the channel. And I'll be back next week with more LeetCode solutions. Thank you guys so much for watching, and I'll see you next time.